So my coworkers have sort of shown you how to do this using our Excel add-in and our web pages, but there's a whole nother side to Calcbench, and that is using the Calcbench API to get all of this data at a grand scale and do analysis both for very big data sets and very quickly, things that would be impossible to do in Excel or reading things on the web page. So I'm going to go through an example sort of in line with what we're talking about today, and I'm going to ask the question, can we do word counts of various phrases related to inflation and supply chain issues and see if they're correlated with the profit margin that companies are reporting? And my goal here isn't really to do very robust analysis, but show people how this is not super hard to get started with. You do not need, you don't need to be a software engineer to get started with the Calcbench API and the tools that I'm going to show you. Some knowledge of programming is going to be helpful, but for instance, we have an accounting professor who this semester is teaching basically the same stuff to his undergrad accounting students as part of a data analytics class. So he knows how to program, but his students don't, and I think they're still able to muddle through this. The software that I'm showing here is the stuff the industry uses, both Wall Street and accounting firms. This is Python, a library called Pandas, a Jupyter notebook. These are all things that researchers and quants are using. So if you learn this, if you teach your students this, it's going to be valuable for them down the road. So I'm going to show some Python code. If you don't know anything, this is going to sort of be Greek, but you'll just have to trust me that this is not super difficult. So we import some stuff. We're using some other libraries, some code other people have written. In general, the algorithm is to go and to get the contents of the management discussion and analysis from the Calcbench database through our API. The management discussion and analysis is not tagged in XBRL. We are doing an additional step to get to that section of the 10K out. So that's a step that you can skip if you want to restrict your analysis to certain sections of the 10K. We have a bunch of sections out of the document, so you can restrict. We have management discussion analysis. We have risk factors. So I'm focusing on management discussion analysis, but you can easily look at other sections of the document. So we use the API to go out and get the contents of the documents. And then we're doing word count analysis. So what this line does is it splits the company up by word. It splits the document into words and then counts those words. And then we're interested in these three terms that we've used throughout this presentation: inflation, supply, and inflationary. So we want to find the number of times that these three words appear in every document. If you were going to do this, this is not very robust. There's much better ways to do this. You would want to use a stemmer so that inflation and inflationary were the same term, and you'd want to find a lot more synonyms. But for our purposes here, this is sort of a simple way to do this. That's the text side of things. For the financial numbers, we want to get gross profit margin. We're going to use the standardized data API endpoint. You saw that earlier when Pranav showed you the standardized data. This is that same data. Just get, we got it for 500 companies here. Again, we're using the 500 companies in the S&P 500. But if you wanted to do this for 6,000 companies, it's not much more difficult. So here, this is the table of profit margin that we got. So this is sort of a spreadsheet, but it's in Python, so it's easy to do more complex operations on. We also get the SIC codes, which Pranav mentioned earlier. Our hypothesis is that companies that talk about inflation and supply chain, they will have lower profit margins. So our proxy for discussing inflation and supply chain is the number of times the term appears in the document divided by the total length of the document. So we do some operations to put them into a format that's easy to graph. And then, so in this chart, you can, we didn't come up with a very good looking trend, but you can see or see the correlation or the lack thereof of the inflation count in the document on the y-axis and the profit margin on the x-axis. So, maybe what we're seeing here is some of the trends that Alex and Ariel pulled out. Maybe they're specific to individual industries or individual companies, and this is not. You don't see this across the economy as a whole. So to look at the industry and the time, the change over time, we can graph the change by industry and time. So again, we're using these terms: inflation, supply, and inflationary. How often do they appear in the documents? We do some operations to make it easy to graph them. And then we plot the change in the occurrence of the phrases over time for these 5 industries: manufacturing. So starting in 2008, which is about when most Calcbench data sets start, and ending in 2000 and ending now. So again, whether there's a broad trend here, I don't know. But maybe, so for instance, wholesale trade, it does seem like there's an uptick. Mining, there might be an uptick. But the point, this isn't this, you can, this can be done. Getting started with a quantitative analysis is not super difficult. You can, we're here to help you if you want to add this to your class or your, what you're doing at your job. Using this data in a quantitative way is definitely doable.